Hello, my friend. I'm glad you're here. Tonight, I'll take you on a calm journey. A story told slowly to help you rest and drift away. There's nothing you need to do now, but listen, breathe, and let the day fade behind you. In the late 1970s, the solar system offered an invitation that could not be ignored. Once every 175 years, the outer giants, Jupiter, Saturn, Uranus, and Neptune, lined themselves up along one side of the Sun. From Earth's perspective, this alignment was a corridor, a cosmic relay in which each world could pass along momentum to a traveler, slinging it farther and faster into the deep. Scientists had known of this alignment for decades, and in quiet rooms they dreamed of a grand tour that might leap from one planet to the next, using the planet's gravity as stepping stones. NASA answered that invitation with two identical spacecraft, simple in appearance but revolutionary in ambition. They were named Voyager 1 and Voyager 2. Each weighed less than a small car, carried dish antennas like white blossoms, and bore within them the modest computers of their time. They were not designed to dazzle with technology. Instead, they were designed to endure, to be resilient against radiation, cold, and time itself. The first to rise was Voyager 2 on August 20, 1977. Cape Canaveral was warm, the air heavy with Florida's salt and humidity. Families of engineers lined the beaches, some with children perched on shoulders pointing toward the rocket that would soon carry their work skyward. Inside the control room, tension was quiet but thick. Decades of planning, late nights of calculations, countless tests of circuitry and code had led to this moment. There is always risk in a launch. Some had already prepared themselves for the possibility of failure. Yet, as the countdown reached zero and the rocket's engines thundered alive, hope surged stronger than fear. 17 days later, Voyager 1 followed. It would soon overtake its sibling, taking a swifter trajectory. For a moment, Cape Canaveral felt like a gateway where dreams passed into reality. Above the roar of rockets, some thought of how these craft would soon leave Earth's skies entirely, heading into places no human eye had ever seen. Imagine being a young engineer on that day. You are in your 20s, perhaps newly married, perhaps beginning your life's work. You watch the rocket streak upward and think of how, if all goes well, this small machine may outlast you, may outlast your children, may still be speaking when your name is forgotten. Few projects carry such weight. Few moments of creation are designed to live longer than their creators. Just 13 days after its launch, Voyager 1 turned its camera back toward home. From over 7 million miles away, it captured Earth and the Moon together in a single frame. The image was small, the Earth no more than a bright dot and its companion a fainter spark. Yet, in that image was something unprecedented. Our world seen from beyond its immediate neighborhood, a family portrait of planet and moon set against the deep dark. It was a farewell of sorts, a last wave before the journey deepened. Pausing here, we can reflect on how fragile the Earth appears in such views. Not a sprawling continent, not a spinning globe full of life, but a speck. For those who saw the picture then, it was humbling. For us now, it is a reminder that perspective shifts everything. From far away, the battles and divisions of humanity collapse into a single point of light. By 1979, both travelers had reached Jupiter. The anticipation was immense. Telescopes on Earth had offered hints, but Voyager's cameras could come near, sweeping past in hours what telescopes had watched dimly for centuries. The discoveries came quickly. A faint ring system was revealed, delicate threads circling the planet where none had been suspected. 3 new moons were spotted, previously invisible from Earth. The largest of Jupiter's known moons, Ganymede, was shown to be even larger than Saturn's Triton, claiming the title of largest moon in the solar system. And then came Europa, gleaming pale and smooth, its icy shell fractured into strange, dark lines. Scientists were startled. This was no dead ball of ice, but a world reshaped from within. Beneath its frozen surface, Jupiter's immense gravity stirred the interior, keeping it warm, perhaps even liquid. A hidden ocean was suspected, one that might be larger than all of Earth's seas combined. In that instant, Europa shifted from obscurity to promise. A place where, one day, humanity might search for life beyond Earth. Ganymede, too, revealed complexities, magnetic fields, icy ridges, and hints of tectonic activity. Each moon, once just a name in a catalogue, became a living world with stories of its own. And then came Io, a world of fire. When Voyager's images arrived, they showed plumes of sulfur erupting hundreds of miles into space, a spectacle no one had predicted. It was the first active volcano observed beyond Earth, and it overturned the idea that small moons must be geologically dead. Io was restless, reshaped by Jupiter's tides. To see volcanoes on another world was to realize that the solar system was far more alive, far more varied than we had ever imagined. And finally, Jupiter itself, the great red spot, a storm larger than Earth, revealed in detail never seen before. Its swirling bands of clouds showed textures and patterns, storms within storms, eddies within eddies. This was not a static scar, but a living tempest raging for centuries. Voyager's cameras made it clear, planets are not still. They are restless. Voyager also measured Jupiter's magnetosphere, its invisible shield of charged particles. It was immense, dwarfing Earth's field. If it were visible to the eye, Jupiter's magnetic halo would stretch across the sky larger than the full moon. Within it, charged particles raced along field lines, creating auroras at the poles, far brighter than Earth's northern lights. Voyager revealed that planets are not only spheres of rock and gas, but also lighthouses, radiating energy and light in invisible forms. For a moment, imagine being there, floating above Jupiter, watching auroras bigger than Earth itself, shimmering across poles that never know stillness. It is a vision at once alien and strangely familiar, a reminder that Earth's own auroras are but whispers of a greater chorus. Jupiter was magnificent, yet it was only the beginning. Using the giant's gravity for speed, both probes fell onward toward Saturn in the early 1980s. This was the second act of the Grand Tour, and expectations were high. Saturn had always been a jewel in telescopes, its rings unmistakable, its pale yellow globe serene. But what Voyager uncovered was a complexity no telescope had ever hinted at. Through its lenses, the rings of Saturn fractured into countless strands, hundreds of narrow bands woven together like threads in an immense tapestry. Some appeared braided, twisting and looping, as though invisible hands had plaited them. Others showed ripples and waves, stirred by the gravity of small, unseen moons embedded within. What had once seemed like a single smooth band was revealed as a dynamic system alive with motion. The rings were not static ornaments, but restless rivers of ice colliding and shifting on timescales both short and cosmic. 4 new moons were discovered during these encounters, adding to Saturn's already crowded family. Each one carried its own story. Some were tiny shepherd moons, holding the rings in place with their gravity, guiding particles as a shepherd guides sheep. Others bore scars of ancient collisions, reminders of a violent past. And then there was Mimas. One massive crater, Herschel, dominated its face, so large that it made the moon resemble the imagined Death Star of cinema. To see such a familiar fictional image reflected in reality was unsettling, yet wondrous. Here was proof that even nature sometimes paints in shapes that echo our own myths. Voyager 1 had a special assignment at Saturn. It was to bend close to Triton, the only moon in the solar system with a thick atmosphere. That choice meant sacrifice. The trajectory that led it to Triton would carry it away from further planetary encounters, sending it instead toward interstellar space. Voyager 2 would take the longer arc to Uranus and Neptune. Triton, shrouded in a golden haze, kept its secrets hidden from Voyager's cameras. The surface could not be seen, but its atmosphere revealed itself, nitrogen-rich like Earth's, with temperatures and pressures that placed methane near its triple point. This meant that methane, a gas on Earth, could act like water does here, evaporating, condensing, raining, and pooling into lakes and seas. Voyager could not see those seas, but it offered the first hint that Triton might be a world with a weather cycle of its own, alien yet strangely familiar. To think of rain falling on another moon, of lakes rippling in an orange twilight, is to realize that Earth is not unique in having skies and storms. Other worlds too breathe, weep, and change. From Saturn onward, the Voyagers diverged. Voyager 1, having given itself to Triton, raced upward out of the plane of the planets, a swift pilgrim heading for the edge of the Sun's domain. Voyager 2 lingered in the planetary plane, continuing onward to Uranus and Neptune. This divergence was no accident. It was planned, a way to maximize discovery. One craft would give us the depth of Triton's atmosphere, the other the breadth of the outermost worlds. Together, they would complete the grand tour. And so, by the early 1980s, humanity had seen Jupiter and Saturn in detail, had discovered moons that were alive with fire and ice, had learned that rings are braided and dynamic, that auroras blaze beyond Earth, and that atmospheres can cloak alien lakes. Already the solar system seemed more alive, more intricate than anyone had dreamed. And yet, even this was still only the beginning. Pausing here, Let us return to the concept that made all this possible: gravity assist. Without it, the Voyagers could never have reached such distant places. To understand it, imagine a dance. A spacecraft approaches a giant planet like a partner moving close, and in their passing, momentum is exchanged. The planet barely notices. Its mass, too great. But the spacecraft gains speed, flung onward like a handoff in a cosmic relay. Each planet was not only a destination but also a partner in the dance, lending its pull, guiding the traveler to the next step. Jupiter handed Voyager to Saturn, Saturn to Uranus, Uranus to Neptune. And beyond Neptune, the final handoff was into interstellar space, into the arms of the galaxy itself. To think of planets not as obstacles but as guides is a shift in perception. They are no longer distant, silent spheres, but participants in a choreography, helping tiny emissaries reach farther than they otherwise could. This dance of gravity is not just physics, it is poetry written in orbits. After Saturn, Voyager 2 continued its long arc outward, alone in its task. The next destinations, Uranus and Neptune, were worlds no spacecraft had ever visited. Telescopes on Earth showed them only as faint, bluish dots, mysterious and cold. Much of what we knew came from mathematics and hints in their light. To approach them directly was to walk into a realm where every detail would be new. In January 1986, Voyager 2 swept within 50,000 miles of Uranus. Unlike Jupiter's roiling clouds or Saturn's pastel bands, Uranus appeared subdued, a calm turquoise orb with little visible texture. Yet beneath that calm, Voyager found surprises. Uranus is tilted almost completely on its side, rotating like a ball rolling around the sun. Its poles point nearly where other planets' equators do, making its seasons extreme. For decades at a time, one pole bathes in sunlight while the other drowns in darkness. Voyager's instruments measured winds sweeping across this tilted world, and found it to be the coldest planet in the solar system, its upper atmosphere chilling below any other giants. Its magnetic field, too, was peculiar. Unlike Earth's, which emerges near the poles, Uranus's field was skewed far from its center, tilted at odd angles, creating an off-kilter magnetosphere that swirled unpredictably. For scientists, it was like watching a compass needle spin without direction. And then there were the moons. Voyager discovered 10 new ones, bringing the total to 27. Some were small, dark fragments shaped by ancient impacts. Others revealed canyons and ridges, landscapes sculpted long ago. The faint rings of Uranus, nearly invisible from Earth, became clearer in Voyager's images. Thin arcs of dust and ice circling a planet that seemed almost shy in comparison to its flamboyant siblings. Pausing here, let us imagine standing on the surface of one of Uranus' moons, looking up at a planet tilted sideways in the sky. The horizon glows dimly with turquoise light. Above, a pale ring arcs faintly, barely visible, and far beyond it, the sun shines as a tiny star. It is an image of strangeness, yet also serenity. A reminder that the solar system contains not only storms, but quiet mysteries. 3 years later, in August 1989, Voyager 2 arrived at Neptune. From afar, the planet glowed a rich blue, though later studies revealed that much of its color came from methane and the scattering of sunlight. As the spacecraft approached, it revealed something unexpected. Neptune, though far colder and receiving less sunlight, had winds stronger than any measured in the solar system. Gales tore across its atmosphere at over 1,200 miles per hour, far beyond Earth's most violent hurricanes. Voyager's cameras captured a great dark storm in Neptune's atmosphere, echoing Jupiter's Great Red Spot. This great dark spot churned for a time, then vanished, replaced by other storms in later years. It was a reminder that planets, like clouds on Earth, know impermanence. What we see at one moment may vanish in the next, replaced by new patterns. Neptune also carried faint rings, arcs of dust that gleamed like threads. Some were uneven, clumping mysteriously instead of spreading evenly. The cause puzzled scientists, though later it was suspected that small shepherd moons might be sculpting them into arcs. But perhaps the most astonishing discovery lay not in Neptune itself, but in its moon, Triton. Voyager 2's close images revealed a surface coated in nitrogen ice, pale and reflective. Yet Triton was not dead. Dark streaks stretched across its plains, and as the images sharpened, they revealed geysers, plumes of nitrogen gas erupting into space, driven by sunlight warming the icy crust. Here was a frozen world, far from the sun, yet alive with activity. Its surface bore strange cantaloupe-like textures, ridges and pits, with no parallel elsewhere. And beneath its crust, scientists speculated there might even be liquid layers, kept warm by tides and radioactivity. Triton orbits Neptune in the opposite direction of the planet's rotation, suggesting it was once a wandering body, perhaps a captured object from the Kuiper Belt. To imagine this capture is to picture a cosmic dance, a drifting world snared by Neptune's pull, reshaped by gravity until it became the restless moon we see today. Each image sent by Voyager traveled for hours across the Gulf. At the time of Neptune's encounter, it took over 4 hours for light itself to cross the distance between the spacecraft and Earth. The control rooms on Earth lived in delay. Every command was a message sent into the past, every reply a glimpse into what had already happened. Exploration at this distance required patience unlike any before. The Voyagers taught us that discovery is not always about speed. It is about waiting, listening, and letting the universe reveal itself in its own time. Voyager 1, though it had skipped Uranus and Neptune, gave humanity one final gift. In February 1990, from 3.7 billion miles away, it turned its camera back toward the solar system. The result was the family portrait, a mosaic showing 6 planets as points of light. Among them was Earth, less than a pixel in size, a pale blue dot suspended in a sunbeam. Carl Sagan's words about that image have become part of our collective consciousness. That's here. That's home. That's us. On that tiny speck lie every human who ever lived, every triumph, every sorrow, every religion and empire, every hunter and farmer, every mother and child. All of it compressed into a dot smaller than a grain of sand. For those listening at bedtime, The reflection is soothing rather than overwhelming. Our struggles, our fears, our urgency, all of it shrinks when seen from such a distance. What remains is wonder and a quiet reassurance that we are part of something vast and kind. With that final portrait, the cameras were turned off. The Voyagers had finished their survey of the outer planets. Ahead lay the long silence of interstellar travel, where discoveries would come not in pictures, but in whispers of plasma and magnetic fields. For more than a decade after Neptune, the Voyagers drifted outward in seeming silence. Their cameras were dark, their planetary flybys complete. Yet their instruments kept listening, tuned to the faint signals of particles and magnetic fields. And then, in 2012, Voyager 1 recorded something no spacecraft had ever felt before. The unmistakable transition into interstellar space. Our star does more than shine. It breathes. The sun releases a constant wind of charged particles, protons, electrons, that streams outward in every direction. Near Earth, this wind is gentle, carrying a few particles in each cubic centimeter of space. But it stretches billions of miles, creating a vast bubble known as the heliosphere. Inside this bubble, we are sheltered. The sun's wind holds back some of the harsher radiation of the galaxy. Outside, the interstellar medium flows, colder, denser, and not shaped by the sun's breath. The boundary between them is called the heliopause, a frontier not of rock or ice, but of invisible forces. For decades, scientists had imagined this crossing would be gradual, the solar wind thinning until it gave way. But the Voyagers revealed a different truth. At the edge, the solar wind collided with the galactic medium, turning sideways, while galactic plasma bent around from beyond. It was not a blur, but a seam, two currents meeting like rivers joining. To imagine this, think of a bay meeting the open sea. Within the bay, the waters are calmer, sheltered by land. Beyond the mouth, waves grow taller, currents stronger. A sailor leaving the bay feels the difference immediately. The Voyagers were those sailors, pushed from calm into swell, their instruments registering the shift. At that moment in 2012, Voyager 1 recorded a drop in solar particles and a rise in cosmic rays. The sun's breath no longer dominated. It had crossed into the galaxy proper. 6 years later, Voyager 2 followed, confirming that the boundary was neither fixed nor smooth, but shifting and rippling like the surface of water. The heliopause, whether on an invisible skin, Voyager's data showed that the heliopause is not still. It billows and bends under galactic pressure, with waves spanning distances 10 times the span from Earth to Sun. Shock waves from solar eruptions travel outward, pressing against the boundary like distant thunder reaching a canyon wall. The spacecraft recorded these tremors as faint whispers, proof that even on the frontier of the sun's breath, weather exists. This was more than science. It was poetry. The sun, like a great lung, exhales into the galaxy, its breath colliding with the larger winds beyond. And we, sheltered within, depend on this cocoon. Without it, Earth would be exposed to galactic radiation far harsher than what now reaches our skies. The heliosphere is not only a frontier, it is a shield, an invisible kindness surrounding us. Yet the heliosphere is not the end of the solar system. Far beyond the heliopause lies the Oort cloud, a vast sphere of icy fragments. None have been seen directly, but their existence is certain, revealed by the long-period comets that occasionally sweep inward. The Oort cloud is thought to stretch nearly a light-year from the Sun, a cathedral of frozen bodies numbering in the trillions. Voyager 1 will not even reach the inner edge for 300 years. To cross it entirely may take 30,000. Only then will it truly escape the Sun's domain in a gravitational sense. Until then, the voyages are still ours, still held by the faint pull of home. Pause here and imagine drifting among those icy fragments. Each comet is a relic from the dawn of the solar system, unchanged for billions of years. Together, they form a vast, silent cloud, a kind of border made not of walls, but of possibility. Beyond it lies the interstellar sea, dotted with stars. Within it, the Sun still claims allegiance. And beyond even that lies the galaxy's own architecture. The Sun floats within a cavity nearly 1,000 light-years wide, called the local bubble. Long ago, supernovae carved it, explosions of massive stars that cleared the region of much of its gas. What remains is thin, almost transparent, allowing starlight to reach us with unusual clarity. It is because of this bubble that our night skies are so rich. If we lived in a denser region, the light of stars might be obscured by dust and gas. Constellations may have been hidden, myths delayed. But here, in this quiet clearing, the heavens shine bright, guiding both navigation and imagination. For future travelers too, this thinness is a gift. A denser medium would batter spacecraft with more dust at dangerous speeds. In the local bubble, the path is clearer, the risks smaller. It is as though the galaxy, in this corner, has made room for exploration. So, where are the Voyagers now? They are just past the heliopause, still within the Sun's gravity, yet already tasting the galaxy. Imagine standing with them. Behind you lies the Sun, distant now, its light a bright star. Around you stretches the mingling zone, where solar and galactic winds meet, invisible currents flowing past. Ahead lies the deep dark of interstellar space, dotted with suns, each with their own bubbles, their own stories. It is a threshold not of stone, but of perspective. For the first time, human-made objects have crossed into the space between stars. They do not rush, they drift. They do not speak loudly, they whisper. And yet, in their journey, something immense has happened. The solar system is no longer the limit of human reach. Even as they drifted farther than any craft before, the Voyagers kept whispering home, their signals thin as candlelight across the dark. Each transmission was weaker than the static of a wristwatch, yet when captured by the Deep Space Network's great dishes, it became legible data, numbers, proof of endurance. And then, in 2022, Voyager 1's reports began to change. The data describing its orientation, how the spacecraft kept its antenna pointed toward Earth, arrived garbled. Instead of steady, clear numbers, there were repeating sequences, nonsense strings, as though the spacecraft was shrugging rather than speaking. At first, the cause was unclear. Radiation? A memory glitch? Engineers traced the problem to the attitude control system, the part of the craft that keeps it aligned. After nearly half a century in space, some pathways had simply worn thin. Imagine a book read so many times that its pages begin to fade, or a road so heavily traveled that its stones crumble. Voyager's systems were showing their age. The solution required ingenuity. Commands were sent to reroute the data through another computer, one that was still steady. Hours passed as signals crawled outward and replies drifted back. Finally, the nonsense cleared. The spacecraft's quiet voice returned, as patient as ever. But in November 2023, a deeper silence fell. Data from Voyager 1 grew faint, then ceased altogether. For a moment, it seemed the traveler had gone beyond our reach. Engineers searched, combed through records, debated possibilities. The cause was traced to a single memory chip, corrupted by time or cosmic radiation. To repair it meant rewriting the software, shifting commands into surviving memory banks. It was a delicate act, like reshelving books in a library where some shelves had collapsed. On April 18, 2024, the attempt began. Each instruction traveled for nearly 23 hours. Each reply took the same time to return. Every step was like holding one long breath, waiting 2 days before knowing if it had succeeded. On April 20, the answer arrived. The signal steadied, the data flowed clear. Voyager 1's voice had returned. Across the control rooms, relief spread slowly. Engineers smiled, some laughed softly, some sat in silence, overwhelmed. The repair was more than technical. It was personal. Many of those engineers had not been born when Voyager launched. Some were younger than the spacecraft they now tended. They spoke of the probes with affection, calling them elderly travelers. And the phrase was apt. Like an elder relative, the spacecraft sometimes faltered, sometimes forgot, but with patience and care could still share its wisdom. To care for Voyager was to bridge generations, the designers of the 1970s handing their creation to new hands, new minds. It was a relay of human effort, one generation whispering to the next, "Take care of them. They still have stories to tell." These episodes remind us that space exploration is not always about sudden discoveries or dazzling images. Sometimes it is about patience. Signals travel nearly 2 days round trip. A command must be sent, then silence endured, then a reply received. Every adjustment is a meditation in waiting. In a world that values speed, Voyager teaches slowness. In a culture that demands constant updates, it offers long silences followed by whispers. And those whispers are enough. Still, age cannot be denied. Power slowly fades. Instruments are turned off, one by one, conserving the small trickle of energy from their nuclear generators. Each shutdown is a farewell, first one sensor, then another, until only the essentials remain. NASA hopes to keep hearing them through 2025, perhaps a little longer if fortune allows. After that, the probes will continue their journeys without us, unbothered, unhurried. When their voices fade, they will still sail onward. They do not need our listening to continue. But the thought that they will no longer answer brings a quiet melancholy. It is like watching the ship vanish beyond the horizon, knowing it still travels, though our eyes can no longer follow. Even when their voices finally fall silent, the Voyagers will keep traveling. They will not stop, not slow, not turn back. Their momentum, gifted by gravity's careful choreography, will carry them onward for millennia. Voyager 1 moves outward at about 3.5 astronomical units each year. An astronomical unit is the span between Earth and the Sun, equal to 93 million miles. Voyager 2 moves a little slower, about 3.1 astronomical units per year. On paper, these are numbers, neat and precise. But to understand them, we must stretch our imagination. An astronomical unit is the distance sunlight crosses in 8 minutes. Voyager travels more than 3 of these vast spans every year, carried outward by its inertia. Today, Voyager 1 is around 15.5 billion miles away. Voyager 2 is about 12.4 billion miles. And yet, in cosmic terms, they have barely begun. Their destinations lie in the far future. In the year 4272, roughly 38,000 years from now, Voyager 1 will pass within 2 light years of a faint star in Ursa Minor. Voyager 2 will approach the star Ross 248 in about 40,000 years. These numbers are almost impossible to hold in the mind. 38,000 years ago, our ancestors painted animals on the walls of caves. They chipped flint tools, followed herds, and watched glaciers stretch across continents. 38,000 years in the future, what will Earth be? What languages will be spoken? What stories told? What beings will call it home? Perhaps none of these. Perhaps something we cannot even name. Through it all, Voyager will simply continue, gliding in silence. To think of such spans is to feel a strange peace. Human lifetimes are brief, but the Voyagers remind us that not everything ends when we do. Some things carry forward, keeping faith with time itself. Even now, though beyond the heliopause, the Voyagers remain within the Sun's gravity. The true frontier of the solar system lies farther still, in the Oort cloud. A vast sphere of icy bodies, relics from the dawn of creation. It is thought to stretch nearly a light year in every direction, 1 trillion comets held loosely by the Sun's pull. Voyager 1 may reach the inner edge in about 3 centuries. To cross it entirely could take 30,000 years. Only then, in a gravitational sense, would it be free of the solar system. Until then, it is still ours. Still a citizen of the Sun, though wandering at the farthest edges of its domain. Imagine the Oort cloud as a cathedral, its pillars made of ice, its halls vast beyond comprehension. Each comet is an ancient relic, untouched since the solar system was born. To drift through such a place is to wander in a museum of beginnings, where every frozen body is a story older than Earth itself. The Voyagers will enter that cathedral quietly, bearing with them not just instruments and antennas, but the echoes of human hands and hopes. Attached to each Voyager is a golden disc, a copper and gold record encased for endurance. It is more than data. it is a portrait of Earth. On it are greetings in 55 languages, images of mountains and rivers, drawings of human anatomy, music from many cultures, and the sounds of our world, the crash of waves, the cry of whales, the laughter of children. And among those sounds is something uniquely human, the recording of brainwaves. Anne Druyan, then a young member of the Voyager team, lay quietly as her thoughts were traced. She thought of Carl Sagan, of love, of eternity. Those waves, invisible yet meaningful, were etched into the grooves of the record. In that moment, love itself became cargo, sent out into the stars. The story of the record's creation is one of urgency and wonder. The team had only weeks to decide what to include. Late nights were spent debating what music could stand for humanity. Should they choose Beethoven, Bach, or Chuck Berry? Should they include mathematical diagrams or photographs of landscapes? Every choice was weighty, for it might be the only message of our species to survive the ages. In the end, they created not a catalogue but a poem. The record is not comprehensive, but expressive. It says, "This is what we value. This is what we sound like. This is how we love." Perhaps no one will ever find these records. Perhaps they will drift forever, silent prayers unopened. But if they are found, what then? Imagine another intelligence, long after our civilization has passed, picking up a small disk of gold. They play its grooves and hear greetings in languages no longer spoken. They hear the music of Earth, the heartbeat of our planet, the laughter of a child. Would they understand? Perhaps not. But they would know this. Someone wanted to be known. Someone wanted to say hello. And in that desire lies something universal. Even if the records are never found, they have already served their purpose. They remind us that humanity is capable of beauty, of generosity, of thinking beyond itself. In the act of sending them, we defined ourselves. And so, the Voyagers sail onward. They may outlast Earth itself. Our planet will change. Continents drift, climates shift, civilizations rise and fall. But those two small spacecraft will keep gliding, carrying with them not only measurements and instruments, but also a fragment of our soul. They are tiny seeds in the galactic wind, borne onward by forces larger than themselves. And as they drift, they tell us something simple. We, too, are voyagers. Our journey is not confined to one planet or one time. It stretches outward into mystery, into tomorrow. When the Voyagers left Earth in 1977, they were launched only weeks apart, siblings bound for the same journey. Voyager 2 departed first, but because its path was longer, it reached the heliopause 6 years after Voyager 1. Both encounters revealed something entirely unexpected. The frontier of the sun was not thinning into emptiness, but thickening. Space near Earth is not empty. The solar wind carries a handful of protons and electrons in every cubic centimeter. As it drifts outward, it grows thinner. Scientists had expected that by the time it reached the edge of the heliosphere, it would have dwindled almost to nothing, and beyond the bubble, the interstellar medium would be only slightly denser. But Voyager's instruments told a different story. Instead of falling, the density rose up to 3 times what models had predicted. It was as if traffic had piled up at the boundary, particles crowding together where the sun's outflow met the galactic flow. The heliopause was not a smooth curtain, but a crowded frontier. Imagine 2 rivers meeting, their waters slowing as they mix, creating swirls and eddies. That is what the Voyagers found. A traffic jam of particles, a weather system on the invisible skin of the sun's breath. This invisible weather is not static. From time to time, great solar eruptions burst outward, sending shock waves racing through the heliosphere. Months or years later, those waves reach the frontier, pressing against the heliopause. Voyager, waiting in the dark, feels them as a rise in plasma waves, a faint tremor across the void. It is astonishing to think of storms that begin on the sun, reaching out billions of miles to ripple against a boundary so far away. A flare that erupts in minutes can echo in Voyager's instruments decades later. The past, in this sense, travels outward in waves, reminders that even distant space carries the memory of our star's heartbeat. The heliosphere is not just a curiosity, it shields us. Galactic, cosmic rays, charged particles born of supernovae and other violent events, stream constantly through the galaxy. The heliosphere deflects many of them, bending their paths, softening their arrival at Earth. Without it, our planet would be bathed in radiation far harsher than what we now experience. Think of it as a cocoon, spun by the sun, fragile yet effective. Inside, life flourishes. Outside, the galaxy's storms rage. We owe part of our survival to this invisible envelope, this breath that pushes back against the wider night. And yet, even the heliosphere rests within something greater. The sun drifts inside a cavity nearly 1,000 light-years wide, carved millions of years ago by multiple supernovae. Astronomers call it the local bubble. Its walls are made of gas and dust, compressed by the explosions of ancient stars. Within it, the interstellar medium is thin and transparent. It is thanks to this bubble that our night skies are bright. If the galaxy around us were denser, starlight would be veiled, constellations dimmed. The myths told by our ancestors, hunters and archers, bears and serpents, might never have been imagined, their patterns hidden. But in this clear pocket, the stars blazed sharp and bright, inspiring both navigation and story. The local bubble also serves exploration. Spacecraft racing outward face fewer grains of dust, fewer hazards, at high speed. For a starship, this region is like a calm sea compared to stormier waters elsewhere. We drift, for now, in a fortunate clearing. The picture that emerges is not of a hostile cosmos, but of layered kindnesses. The sun's heliosphere shields us from radiation. The galaxy's local bubble offers us a transparent view of the stars. Even the density at the heliopause, though puzzling, speaks of boundaries that slow and soften cosmic storms. To realize this is to feel gratitude. We are small, but the universe has given us space to grow, to look outward, to send ships like Voyager into the dark. The void is not only emptiness, it is also protection, clarity, and invitation. Pause here, my friend, and imagine two Voyagers floating at the seam of these shields. Behind them, the sun's breath. Around them, the thinness of the bubble. Ahead, the wider galaxy. They are at once sheltered and exposed, both safe within a cocoon and already beyond it. Though space feels silent to our ears, the Voyagers remind us that silence is never complete. Far beyond Pluto's path, Voyager 1 began to sense a faint, steady tone, about 3 kHz. A plasma wave hum that endured nearly 3 years. This sound was not random static, but the resonance of electrons shifting in the interstellar medium, vibrating at radio frequencies. Over 1 billion miles of travel, the tone scarcely changed, steady as the breathing of the cosmos. To be clear, there is no sound in the vacuum of space, no air to carry vibrations. What Voyager detected were electromagnetic waves, oscillations of charged particles. Scientists translated these frequencies into audio so that human ears could listen. And when they did, what emerged was a long, steady hum, strangely calming, as though space itself were sighing. Imagine lying in bed and hearing the gentle buzz of cicadas or the low drone of a distant organ. That is the quality of Voyager's plasma song, not dramatic, not frightening, but patient and continuous. It reminds us that even emptiness has texture, that the void is not silent, but humming. Elsewhere in the cosmos, signals are less steady. In 2007, astronomers combing through archived radio data discovered a millisecond flash, now called a fast radio burst, or FRB. Since then, dozens more have been found, arriving without warning from galaxies far away. Each burst lasts less than the blink of an eye, but in that instant releases more energy than the sun produces in days. The cause remains a mystery. Some point to magnetars, neutron stars with magnetic fields so intense they warp space around them. Others suggest collapsing stars or interactions with black holes. Whatever their origin, FRBs remind us that the universe can shout as well as whisper. To catch one is like hearing a lightning strike on the other side of an ocean. Sudden, powerful, brief, and haunting. Closer to home, Voyager and other spacecraft have captured what scientists call chorus waves, electromagnetic emissions from planetary magnetospheres. When translated into audio, they sound like flocks of birds, rising and falling in strange harmony. Jupiter's magnetosphere produces some of the loudest chorus waves, tied to the auroras that blaze at its poles. Saturn, too, sings in radio tones, shifting as its seasons change. Even Earth hums with chorus waves, heard by satellites that orbit within our magnetic shield. The universe, it seems, is full of choirs, each planet singing in its own dialect. Mars, a crunch and a squeal. Even worlds without thick atmospheres have voices. On Mars, NASA's Perseverance rover once recorded the crunch of its wheels across rocky soil. Beneath the rumble was a high-pitched squeal, unexpected and unexplained. Perhaps it was the resonance of metal against stone, or something stranger in the thin Martian air. Whatever the cause, It became another note in the growing symphony of space. Taken together, these sounds, plasma hums, radial bursts, planetary choruses, Martian scrapes, remind us that silence is never truly empty. The universe is alive with vibrations, waiting for instruments to translate them into forms we can perceive. And beyond the science, there is comfort here. For those listening at night, seeking rest, the idea that the cosmos hums with steady tones can be soothing. It is like falling asleep to the rhythm of waves on a distant shore. The sounds are faint, but they are constant. They tell us that even in the deepest dark, there is presence, not absence. So imagine, my friend, the Voyagers moving through this symphony. They are like small instruments themselves, adding their faint transmissions to the chorus of the cosmos. They listen, they hum, they drift, and in their drifting, they remind us that the universe is not silent, but filled with voice. As the Voyagers sail outward, scientists and dreamers already imagine their successes. Plans for a new interstellar probe have begun to take shape, perhaps to be launched in the 2030s or 2040s. It would be swifter, hardier, designed from the start to travel far beyond the heliopause to distances 10 times greater than Voyager could hope to reach. This new traveler would carry instruments of a kind impossible in the 1970s, cameras that could photograph the solar system from outside, sensors that could map the heliosphere's long tail, detectors sharp enough to sample the subtle chemistry of the interstellar medium. Where Voyager offered glimpses, this probe could provide panoramas. It would not just whisper of the galaxy beyond. It could show us in detail how our star interacts with the wider night. Engineers dream of such a craft not because Voyager failed, but because Voyager succeeded. These small machines, built with less computing power than a modern wristwatch, carried us farther than we thought possible. If so much was achieved with so little, how much more could we see with today's tools? For now, however, our attention rests with the Voyagers still whispering. Their signals, only about 22 watts, are no brighter than a refrigerator bulb. By the time those photons reach Earth, they are trillions of times weaker than the energy of a watch battery. Yet Earth hears them, thanks to the Deep Space Network. 3 great antenna arrays in California, Spain, and Australia form a global triangle. As Earth rotates, one is always facing the sky, always listening. They're like giant ears cupping the void, catching faint whispers that would otherwise be lost. Technicians walk the grounds beneath their immense dishes, maintaining the machinery, checking signals, making sure that the ears remain open. There is poetry in this image, humanity leaning into the darkness, hands cupped, listening for the voice of its farthest emissaries. The distance is vast, the voices faint. But the act of listening itself is an affirmation. It says, "We care, we are patient, we will wait." In 2017, Voyager 1 responded to a command to fire backup thrusters that had not been used since 1980. For 37 years, they had lain dormant, untouched by human instruction. And yet, when asked, they worked. The small puffs of gas nudged the spacecraft, adjusting its orientation, so its antenna could stay pointed home. It was a moment that startled even the engineers. What else in our world works perfectly after nearly 4 decades of disuse? The success was more than the triumph of engineering. It was a reminder that foresight matters, that choices made carefully in the past can bear fruit in the far future. Why do we keep listening to these faint signals? After all, the data now is not dramatic. There are no new photographs of planets, no breathtaking discoveries of volcanoes or geysers. What comes are numbers, particle counts, plasma densities, magnetic readings. But to listen is to honor the journey. Each signal is a continuation of a story begun in 1977. Each whisper proves that endurance is possible, that something made by human hands can survive and speak across half a century. And beyond science, there is something deeper. Listening itself becomes a ceremony, an act of connection across billions of miles. Perhaps one day a new probe will take up the mantle, carrying sharper instruments, stronger transmitters, a brighter flame. But the first steps belong to Voyager. They remind us that exploration begins not with the loudest voices, but with the patient ones, those willing to whisper for decades and trust that someone, somewhere, will be listening. The Voyagers were not born as legends. They were, at the start, extensions of earlier spacecraft, descendants of the Mariner probes, built to stretch our reach a little farther. Their electronics were modest, even by the standards of their own decade. Inside, each craft rested computers with about 70 kilobytes of memory, less than the size of a single modern photograph. Their processors could perform only tens of thousands of instructions per second, millions of times slower than the devices we carry in our pockets today. And yet, this simplicity was their strength. Complexity can falter. Fragile parts can fail. The Voyagers were designed to endure. Their code was tight and careful, their circuits built with redundancy, their systems rugged against radiation and cold. They were not meant to dazzle. They were meant to last. For data storage, the Voyagers carried digital 8-track recorders, not unlike the music tapes that filled homes in the 1970s, though designed for space. These machines could capture bursts of discovery, images of moons, fields of particles, and then slowly play them back toward Earth. The data trickled home at bite rates that today would feel impossibly slow. A few hundred bits per second, a whisper thinner than static. Yet those whispers contained volcanoes on Io, braided rings at Saturn, storms at Neptune, plasma waves at the heliopause. It is humbling to think all that wonder was carried across the void by computers smaller than a child's toy. It proves that exploration is not always about power, but about patience and resilience. But perhaps the most famous cargo the Voyagers carried was not their instrument, nor their computers, but their golden records. Fastened to the side of each craft was a disc of copper plated in gold, designed to endure 1 billion years. It was a message in a bottle, a greeting from Earth to whatever intelligence might one day find it. On the record are greetings in 55 languages: ancient Sumerian, modern English, Hindi, Mandarin, Arabic, Swahili. Each one says, in its own tongue, "Hello." 90 minutes of music follow, spanning continents and centuries. Bach and Beethoven, Senegalese drumming, Peruvian panpipes, Navajo chants, a jazz standard, and the voice of blind Willie Johnson singing, "Dark was the night, cold was the ground." There are sounds of earth, wind in the trees, thunder, whale song, the laughter of children, the cry of animals. There are 115 images etched in analog form. Mountains, rivers, people, architecture, scientific diagrams, even a photograph of a mother nursing her baby. The record is, in essence, a love letter to existence. Among the most poignant inclusions is the recording of human brainwaves. Andrean, then a young member of the Voyager team, lay quietly as her thoughts were traced. She thought of history, of civilization, of the planet itself. And she thought of love, of Carl Sagan, who would later become her partner. Those thoughts, invisible but real, were etched into the grooves of the golden record. In that act, love itself became part of humanity's gift to the stars. To imagine it is to feel something rare, a human heartbeat transformed into data, a private thought turned into an eternal message. Perhaps no alien will ever decode it, perhaps no one will ever hear, but it does not matter. The act of sending was itself the meaning. The record was assembled in a rush, just 6 weeks from start to finish. Scientists and artists debated what should be included, which music best represented Earth, which images captured our essence. Some argued for the inclusion of contemporary politics, others for timeless universals. In the end, they chose not to present our conflicts, but our hopes. The record was not a catalogue of everything we are, but a sketch of what we wish to be. It is easy to imagine those late nights Carl Sagan, Timothy Ferris, John Blomberg, Andrean, and others gathered around tables, stacks of records and photographs beside them, coffee cooling in mugs, time running short. They knew their work was not just science. It was art, diplomacy, philosophy. It was humanity speaking not to itself, but to the cosmos. Even if no one ever finds the golden records, their meaning is clear. They tell us that when faced with the opportunity to send something of ourselves into eternity, we chose beauty. We chose music, laughter, greetings, love. We did not send blueprints for weapons or manifestos of fear. We sent a lullaby. For those listening tonight, this thought can be calming. Somewhere beyond the heliopause, 2 small spacecraft carry with them the sounds of our world. They drift in silence, but attached to them is a chorus of voices saying, "Welcome." It is, perhaps, the gentlest act humanity has ever performed. One day soon, the last instrument will be turned off. One day soon, the small nuclear heart of each Voyager will no longer have enough warmth to power transmitters or sensors. The faint voices will fade. At first, there will be silence in the data streams, then silence in the control rooms, and finally, silence in our awareness. Yet this will not be an ending. It will be a continuation. The Voyagers will still drift outward, untouched, unbothered, carrying their golden records and their quiet momentum. They will pass into distances where no message can follow, but their journey will remain, patient and unbroken. Picture them now, two tiny sparks gliding outward. Their antennas, once turned toward Earth, will rest in silence. Their instruments, once alert, will sleep. Yet the crafts themselves will remain whole, smaller than dust compared to the stars they pass among. Around them stretches the local bubble, vast and thin, carved by ancient supernovae. Beyond it, the galaxy swirls with billions of suns, each with their own planets, their own stories. The Voyagers are not rushing, they are not chasing. They are drifting, like seeds carried by a cosmic wind. This image is calming. Our world is noisy, urgent, filled with rushing. But Voyager is not rushing. Voyager is patient, moving at its own rhythm, at a scale of time so vast that human years vanish like seconds. It was fortune that allowed these ships to be launched when the planets aligned, a chance that comes only once in centuries. It was fortune that their rockets rose successfully, that their instruments endured, that their voices still reach us after nearly 50 years. And it is fortune still that we can hear them. Faint, fragile signals across the gulf of space, caught by giant dishes on Earth. Each message is more than data. It is a reminder that connection is possible across impossible distances, that patience makes bridges where speed cannot. And so, my friend, if your eyes grow heavy, let them fall. The probes will continue on their way whether or not you are awake to notice. They do not need us to move forward. Out there, the hum of plasma is steady. In here, the night is kind. Take a breath and let it out slowly. Imagine those two sparks gliding farther with every heartbeat. As you rest, they drift. As you sleep, they continue. There is no urgency. There is only endurance. For a moment, let us pause. Numbers and names can rest now like stones placed gently on the ground. Somewhere, far from here, a faint signal travels across the dark with all the time in the universe. We listen when it arrives, and we wait kindly when it does not. In that waiting, there is no hurry, only patience, only trust. The Voyagers remind us we do not need to know everything now. Discovery is patient. Time is generous. The universe will unfold when it is ready. The gentle work of distance. Picture again the sun's far boundary, the heliopause, where particles crowd like streams, meeting at a bend in the river. Beyond it, the local bubble stretches wide and thin, giving us bright skies filled with constellations. Closer to home, auroras shimmer, plasma waves sing, and spacecraft whisper. Each layer is a reminder that space is not empty, but alive with presence. The Voyagers themselves are part of that presence. They hum faintly, they drift steadily, they endure. One day, they will be silent. But silence is not absence. It is continuation. They will keep sailing, carrying with them greetings, music, laughter, and the sound of love turned into brainwaves. Imagine them once more, a pair of small machines, no larger than a room, sending out a light no stronger than a household bulb, crossing gulfs wider than imagination. Imagine giant dishes on Earth, tilting like ears cupped around a candle flame. Imagine golden records spinning silently, carrying words of welcome and songs of beauty, not because we knew who might hear them, but because we wanted to say hello. This is our outstretched hand into the dark. This is humanity at its gentlest. Take one last resting breath. If your eyes are heavy, let them close. The Voyagers will keep traveling, whether we listen or not. Out beyond the sun's faint shore, the hum is steady. And here, beneath our pale blue sky, the night is kind. And so our story comes to rest. May your night be gentle, your dreams untroubled, and your sleep deep. Until next time, good night.